I'm Ravi Puwala. I'm currently the Vice President of Strategic Partnerships at Harman. Harman is focusing a lot in terms of building connected vehicle platforms, starting from 5G telematics platforms, connected infrastructure, multi-access edge computing platforms, and recently starting to focus on cybersecurity innovation. I've joined Harman about an year ago. Prior to Harman, I was the founder and CEO of a company called Savari, which got acquired by Harman about a year ago. Software-defined car is growing rapidly, and it will impact many parts of the automotive industry, including technology, market segments, business models, regulations, and legislations. Today, most cars are getting connected with 4G or the 5G cellular radio. We at Harman believe by 2025, 90% of the cars will be connected. This brings in an important change in terms of how automotive OEMs would look at technology convergence. It will start with in-vehicle platforms moving away from CAN, FlexRay, LIN type of interfaces to Ethernet. This also brings in a huge change in terms of where they should be investing their computing power, whether it has to be in the vehicle, in the edge, or in the cloud. As the OEMs are focusing towards service-oriented applications and gateways, it brings in new use case scenarios. We all know today most consumers are focusing on audio streaming applications like Spotify. We have seen introduction of video streaming services like Netflix coming into vehicles. We've also seen many announcements from leading car makers focusing on extended reality that brings in augmented windshields. It also brings in metaverse type of applications, which includes VR gaming, VR virtual concerts. And of course, we all know about different levels of automation. And if we are expecting automotive market, which has about $2.5 trillion worth of data that's coming up in the next 5 years, unlocking this cannot be possible unless there is a significant investment in cybersecurity. Today, auto OEMs are faced with various regulations, mainly coming from UNIZ, United Nations enforcement in terms of regulations and standards. There are two regulatory requirements, especially the UNIZ R155, which stands for the Cybersecurity Management Systems, and also the UNIZ R156, which focus on the Software Update Management Systems. Both the CMS and the SUMS is a regulatory mandate, which means there are legal implications if the auto OEMs do not comply to it. Today, auto OEMs cannot sell vehicles in about 54 different countries without compliance certificates to these mandates. It starts from July 2022 for new vehicle types, and it will start from July 2024 for all new vehicles. In addition to these UNIZ regulations, R155 and R156, you have many regulations that are imposed by states like California, who have privacy laws, countries like China, who have a cybersecurity law, a data security law, and also a personal information protection law. These regulations and standards are becoming a big impedance, not just on the auto OEMs, but also on the suppliers in terms of how to meet for these standards. But the responsibility do not stop at the regulations itself. They need to think about how to do beyond if they are looking at unlocking billions of dollars of revenue from the consumers. Let's look at where auto OEMs need to invest in order to meet a lot of these cybersecurity regulations and building a strong foundation so that they can unlock billions of dollars of service revenue. Many of this starts with investing in and improving the cybersecurity defense inside the vehicle. Today, we have 3 generations of vehicular architectures. The first vehicular architecture started in the early 2000s, which is very centric based on the ECUs. Many cars have about 170 ECUs. It is migrating to a next generation vehicle architectures, which is focused on domain controllers and zonal controllers. So when we look at endpoint detection, OEMs need to invest in platforms like the ECUs, TCUs, domain controllers, zonal controllers, in order to do the endpoint detection and response. The next level of impedance comes in how to focus on network level detection. A lot of this investment is going into gateways that are going to be central part of the vehicular architectures. But in our opinion, that itself is not sufficient. We at Harman believe computing inside in-vehicular platforms is not reasonable, because the cybersecurity attacks are getting more sophisticated. They use a lot of brute force methodologies, and eventually it becomes a lot of denial of service. We have seen many types of hacks coming in through the Wi-Fi radios. There's a recent Tesla attack that was exposed. How using the Wi-Fi as a mechanism that anybody can steal a Tesla Model 3 vehicle. We've also seen vulnerabilities in the ultra wideband radios that we used to kind of exploit the keyless entries. We've also seen the cellular radio as a primary interface where the attacks from thousands of supplier vulnerabilities are getting exposed into connected vehicles. It may not be a problem today, but when these vehicles become different levels of automation, it becomes a real issue on where they should be investing their dollars. And this is the reason we at Harman started to focus on becoming a managed cybersecurity service provider, where we are going to invest a lot in the edge platforms, and these would be done on behalf of the auto OEMs. This gives a balancing act, whether the auto OEM should be investing in the in-vehicle computing resources, or if they can rely on security access, service edge type of platforms that they're building for the auto OEMs. In addition to the SASE, there are many other types of technologies we are looking at, and together the key platform technology we are building will become a flagship service in meeting the cybersecurity regulatory compliances, but also in allowing to deploy secure software services for the consumers on behalf of the auto OEMs. Harman is focused on protecting the in-vehicular assets from the edge by becoming a managed cybersecurity service provider. What we have seen traditionally has been done is that the industry has put a lot of emphasis on cybersecurity detection and response, but there has not been any investments or technologies that have been deployed that focus on real-time prevention of cyber attacks and emphasizing the use of the edge service architectures. So today, a traditional vehicle security operations center focuses on key management, it focuses on data leak prevention, and potentially also provides a lot of deep dark web type of tools, which is used to manage the compliances for cybersecurity regulations. But what we are doing at Harman is to building a set of strategic partners that brings in various types of security operations that have been prevalent in the enterprise networking world, which includes security incident event management, endpoint detection, network detection, and instead of building these legacy siloed security tools as independent platforms, we are unifying into a single architecture where these integrated applications will build an open external detection and response mechanisms. This open XDR, which is an industry standard, will become a singular platform in order to monitor an entire vehicle attack surface, which will have the full visibility. We also focus on normalizing different type of events, enriched data coming in by doing a data fusion. And most importantly, we will be deploying AI and ML-based techniques to do incident correlation. Combine this with an automated intelligent response will revolutionize how auto OEMs can create a single security framework that masks connected vehicles against cyber threats, and also minimizes the OEM's liability and risk.